Good morning, students. Today we are going to start with a very new chapter of mathematics, that is volume and surface area of class 9th. In this chapter we'll learn about how to find a volume and the surface area of a solid figure. That is completely three-dimensional figure. We'll talk one by one. We'll take some examples also, and we'll see how the volume and surface area is calculated. First of all, let us understand the basic concepts regarding the 3D objects and the 2D objects. So first is plane figures. The figure which we can draw on a piece of paper, which lie on a plane, are called plane figures. Examples: circle, square, rectangle, etc. Right? And the solid figures is the 3D shapes which occupy some space are called solid figures. For example, we have cube, cuboid, sphere, etc. So every 3D figure, the solid figures, has some kind of 2D net diagrams. You might have learned about 2D net diagrams in your previous classes, right? From 2D net, we obtain a solid figure. So volume, the simple definition is a space occupied by any solid shape is the capacity or volume of that figure. The unit of volume is cubic units, right? So the cubic units arises from multiplying three different values having the same unit. Like if it is meter, so meter multiplied by meter will give you meter cube. The surface area, the area of all the faces of the solid shape, is the total surface area of that figure. The unit of surface area is a square unit because it's area, so it is a square units. Lateral or curved surface area. The surface area of the solid shape after leaving the top and bottom face of the figure is called the lateral surface of the shape. The unit of lateral surface area is a square unit, so it goes with curved surface area also. Curved surface area is in curved solid shapes, like we have cylinder, we have cone, etc. First of all, we'll talk about cubes and then we go to cuboid. Surface area of a cube. Cube is a solid shape having 6 equal square faces. So 6 equal square faces will be having this is how the figure looks like. All right, this is a cube shape. It has 6 faces in total. Suppose you are sitting in a room surrounded by 4 walls and one top, that is ceiling, another is floor, that is bottom. It's total number of faces. If you imagine your room as a cubical shape, so it has got 6 different faces. Okay, when we talk about cubes, it is made up of squares. Okay, so it has got equal square faces. Total number of 6 equal square faces. That is total surface area. When you leave the top as well as the bottom, that becomes the lateral surface area of the cube. So cube is a solid shape having 6 equal square faces. If you look at the diagram here, this is the edge, this is another edge, and the height is also the edge. So everywhere the edges are here. Okay, so lateral surface area is 4L square. So if you see, when we talk about lateral surface area, we always talk about the 4 faces, leaving the top as well as the bottom. So 4 faces, as it is made up of a square, area of each square, 4 faces square, will be side squares, or we can call it here, if I'm taking here as E, so E square plus E square plus E square plus E square, like 4 faces square, so it becomes 4 E square, right? When you talk about the total surface area, it becomes 6. right? So simply 6 means what? You add plus the bottom as well as the top ones, it becomes 6e square or 6l square, right? The volume is obtained from volume of a given solid figure is given as area of the base multiplied by height. So area of the base is e square multiplied by the height, which is also e, gives you e cube, that is l cube. Here it is taken as l. Diagonal is given as a square root of the length square, which is e here, the breadth square, which is again e, and the height square, which is again e. So it will give you a square root of 3 e square. So square root of 3 is taken out, and e square comes out of the square root, becomes e only. So we simply write a square root of 3 and e, or 3l. L is the edge of the cube. Surface area and volume of a cuboid. Cuboid is a solid shape having 6 rectangular faces at right angles. Look at the figure here. For more clarity, let me draw the figure for you. Two rectangles, and joining the vertices here, it gives you the cuboid. So cuboid is simply a structure of a room where it has got 4 walls and 1 ceiling, and another is bottom, that is the floor. So finding the lateral surface area, which is also called as area of 4 walls, which you have already learned in your previous classes. Area of 4 walls, which is given as perimeter multiplied by height. Perimeter is twice of L plus B multiplied by H, which is simply informed 2H L plus B. Area is in square units, that is the unit of lateral surface area, and total surface area is the area of each and every faces of the cuboid. So if you take this as L, this has B breadth, and this one as height, as you know the property of rectangle, all the opposite faces, all the opposite sides of the rectangles are equal. So this is L, so this is also L, H is here, B is here, so that becomes B. Similarly, this one is H, this one is H, right? This one is L, this one is also L, this one is also L. So you get 4 B's, 4 L's, and 4 H. So if you add all together, all the areas of the given faces, you get 2 into LB plus BH plus LH. All right. And volume of the cuboid is area multiplied by height, or area of the base. Area of the base is length into breadth multiplied by the height. Diagonal is given as a square root of L square plus B square plus H square. So that is the basic formula which is used to solve the given questions in the exercise as well as from the examples. You should practice examples first and then move to the exercise questions. And if you face any problem, you can ask me in the virtual class. That's all from today class. Thank you.